All right, happy Monday, everybody. Hope you guys are doing well, and hope you all had a good weekend. We'll continue on. We are in chapter 4, and we left off on Friday. So on Friday we left off, we talked about describing a relationship between two numeric variables. And we said when you're going to describe a relationship, there are 3 things to cover. Okay. And we said that would be the shape. And as far as shape, we said it can either be linear or nonlinear. We had the direction. And this would either be positive, negative, or neither. And lastly, we have the strength. And this could be strong or weak, maybe moderate. All right, and so we've talked about shape and direction, and so today we'll cover strength. Okay, so as far as the strength of a relationship goes, so the strength of a relationship, again, between two numeric variables. The idea here is that if the relationship is strong, then it means you can make good predictions of one variable based on the other. Okay? We can predict one variable quite well if we know the other variable. So the idea here is that there is not much scatter around kind of your trend line. Okay, we have and on the other hand, a weak relationship. This means that while we can make predictions, they're not going to be as precise or accurate. Okay, so our predictions will not be as precise. Or accurate, or in other words, there is lots of scatter. Okay, and so, if I plot my x and my y variable here, and we have something that looks like this, okay, this would be a strong relationship. Okay? Because given, if I say, here is a particular value of x, make predictions for y, our predictions for y would all be kind of within this window. Because for this value of x, we would just go to our data and say, oh, okay, this is our kind of our predictions for y. There's just a little bit of scatter there. Over here, I'm going to just have something like this. We would say this has a weaker relationship. Okay? Because over here I could say, here's my x, what would we predict y to be? Well, then kind of my window for y is now much taller, right? Like y could be anywhere in between here and here. And there is still an overall trend, positive trend, but our predictions, our prediction is much taller or wider. So this would be a weak relationship. Okay. All right, and so just like many other things in statistics, rather than just using the terms strong or weak, we like to quantify these things. And so we have a statistic, a summary statistic that captures the direction and strength of a relationship between two numeric variables. And that thing is called the correlation. Okay, so we have the correlation. I guess the full name is the correlation coefficient. Okay, the correlation is a summary statistic that quantifies the direction and strength of a relationship between two numeric variables. Okay. The correlation, the symbol for correlation is R. So like relationship. So the symbol is R, and the interpretation for correlation only makes sense if the relationship is linear. Okay, so it only works if the relationship is linear. But technically you can calculate the correlation for any two numeric variables, even if it's not linear. You can it's just a formula, you can just plug in your values and it will spit something out, but that value will not make sense if the relationship is not linear, okay? So you can still calculate R even if the relationship is nonlinear. But the value will be meaningless. So how can we tell if something is linear or not? How can we tell if the relationship is linear? What do we do? What's step 1 or step 0? Okay. We have to make a graph first, right? So we should always make a graph first. First to decide if it is linear. We should always make a graph first to decide if it is linear, and then we can calculate correlation and make an interpretation. Okay, so this is how correlation works. Okay, so correlation is always between 0 and, I'm sorry, -1 and 1. Correlation is always between -1 and 1, inclusive. Okay, the sign of R, the sign of your correlation is the direction. The sign of R is the direction of the relationship, meaning if R is positive, the direction is positive. If R is negative, the direction is negative. Okay, I'll just write R positive means positive direction. Okay. And then if R is close to 0, the relationship is weak. And if R is far from 0, meaning it's close to 1 or close to -1, the relationship is strong. Okay, but again, this only makes sense if the relationship is linear to begin with. Okay. Okay, so let me just draw a few pictures for you guys to kind of give you an idea of how correlation works. All right, so if I have let's try this. Okay, here R is equal to 1. Okay, you have a perfectly straight line. Okay, the dots are in a perfect straight line. Okay, no scatter. So if I know the x, if I know x is right here, then I know my prediction is right here, okay? And there's no question there. Whereas, and then over here, okay, what do I have here? It's not supposed to be. R here would be -1, okay? Again, perfect straight line. Okay, something like this. R is probably 0.95 if I had to guess. Okay. So, I'm just eyeballing this number. Don't say how did I calculate this, but I would guess something R is something around 0.95, and then as the amount of scatter increases, this might be something like R's 0.65. I don't know, I'm just making stuff up here, okay? Until you get to you guys see these dots? I don't know if they're too small. Okay. So down here, this would probably be R equals 0. Right. And then, in the opposite direction, a little bit more scatter, a little bit of scatter here. Maybe R is equal to -0.9. Again, just eyeballing things. I don't know what this would be. R is -0.6. Not sure. Okay, but this is kind of the idea here, right? And so these interpretations of R make sense because in all of these the relationship looks kind of linear. However, well, with the exception of R equals 0 here. However, if we had a nonlinear relationship, you can still calculate R, it doesn't tell us much. Okay, so if I have this, okay, is there a relationship between X and Y? Okay, and your answer there is yes, there's a relationship, right? Okay, however, that relationship is not linear. Yes, question?
What if there's a flat line, flat straight line?
Oh, okay, yeah, I'll get to that also, okay? Okay, but the relationship is not linear. All right, and so over here, this would be something like the correlation here would be 0, okay? And in this graph, the correlation will be 0, okay? So even though R is 0, there is a relationship. It's just not linear, okay? But let's say you have something like this. Okay, you have kind of this exponential-ish thing, and it takes off. If you calculated the correlation here, correlation will probably be something like 0.93, okay? And so if you didn't look at the graph, you might think, oh, there's a strong positive linear relationship, okay? But that is not correct, okay? So, you know, if you only saw R equals 0.93 and did not look at the graph, you may think there is a, you know, positive, strong linear relationship. But that's not the case, okay? That's not true. So, you know, if you don't, so all of this to say, it's very important that we look at the graph first, okay? We have to create a graph to make sure it looks linear so that our interpretations of R make sense. Otherwise, sure, you can calculate R. You're just throwing numbers into a formula, but the interpretation won't make sense. Okay, we are actually not going to learn how to calculate correlation by hand. There is a formula, it's programmed into computers, but we will not learn how to calculate R by hand. Generally we just throw it at the computer and say, computer, here's a bunch of numbers, calculate the correlation for me, okay? So either correlation will always be provided to you, or you'll be given the computer to use it, okay? So I'll just say it will be provided in the problems. Okay, let's have our first clicker question. And here I will okay, and so I'm going to say, and here R is equal to -1. Okay, and then I'm going to draw another graph here, another plot. And then your answer choices are R is equal to -1. B is R is, you know, close but not equal to -1, so e.g. -0.9 to -0.9599. C, R is close to 0. D, R is negative, we'll say -0.5. Okay, and this is, I guess so. Okay, so this is the plot. This is the plot in question. Okay, and so you want to discuss with your neighbor what the correlation here is. Maybe I'll, So what is the R here? Okay, are you guys decided? I'm going to close the poll here. Okay, let's take a look. Oops. Okay, yeah, most of you guys got it. It's R is equal to -1. So one thing to note about R is R does not depend on slope. So here, whoops, R is equal to -1. R does not depend on slope. Okay, so even though this line is much more steep and this is more shallow or whatnot, because R only talks about the direction and the strength, they are the same. We have a perfectly strong relationship, and it's in the negative direction. Therefore, R here is -1 in both of these cases. Okay. You know, shallow slope, however, is different from having no slope. Oops, okay. Okay, so having a shallow slope is different from having no slope. So if I have this, oops, okay, what is R in this case? R would be 1, -1, 0, something else? R here is 0, okay? So if you have a little bit of slope, okay, it's going to be -1, or a little bit of slope going up, it'll be +1, okay? But if it's completely flat, then there is no relationship, okay? So this indicates no relationship between x and y. And it feels like, oh, there's a linear relationship because we can draw a straight line. But that's not true. Okay? So for example, let's say you surveyed 20 people, right? Okay, you surveyed 20 people, and you said, how much money do you make? So we'll say your income. We'll ask, you know, what's your annual income? So you get all sorts of different numbers. And then you ask, how many fingers do you have? All right. And then these 20 people you survey, they all say, I have 10 fingers. Okay. So is there a relationship between income and number of fingers? No. Okay. I mean, can you predict someone's fingers? Well, yes, you could predict the number of fingers. You know, probably it will be right 99% of the time, but it's not because you knew their income. Okay. So the income isn't giving us any information about the number of fingers somebody has, and so the relationship between x and y, there is no relationship. Okay, no relationship between these two variables. let me pull up a page from our textbook. All right, so this plot kind of shows the dangers of just calculating R without looking at a scatter plot. Okay, so if in all of these, all four plots have R equal to 0.86. Okay, all four of these plots have the 0.8182. Okay, all four of these plots have the same correlation, but the interpretation of the correlation really only makes sense for this one. Okay, this, it makes sense here. Okay. But in all of these other ones, it does not make sense to use R equal to 0.82 as an interpretation of the correlation here, okay, or interpretation of the relationship between X and Y. So right here, over here, it looks like there would be a straight line relationship between all of our dots, okay, with the exception of one point. We have one point that stands out, and this point is kind of ruining it. So here, R should probably be +1. R should probably be 1. But there is one outlier here. And correlation doesn't know this. You're just throwing the numbers in the formula and it's spitting something out, okay? And probably I would suspect that this was a typo, okay? I would suspect somebody entering the data made a typo or something, and because if everything looks like this one is just very strange. Or perhaps there is a strange phenomenon that just says for this particular value it spikes up, okay? But I would suspect, and you would want to do more research. You'd probably want to take repeated measurements at this location and see if you still get this value. And if you do, then you've got an interesting phenomenon going on. Otherwise, I would suspect it's probably a typo in something like this, okay? So it requires more investigation, okay? Okay, over here, pretty much, this is kind of like the fingers scenario, but you asked a question where every single person, their answer to the first question was 8. Okay, their answer to the first question was 8, and you got a variety of answers for the second question. Okay, and so really there should be no relationship between X and Y, but one of the persons happened to have 19. Okay, so it's like almost everybody has 8. You have maybe one person who has 19 or just some strange exception. And because you have one person, again, who's an outlier, who's very different from everyone else, now you're trying to establish some kind of relationship and saying having more of X makes, increases your Y. So it would be like, is there a relationship between fingers and income? And, pretty much your entire data set, everybody says I have 10 fingers. You come across one person who has 11 fingers, and maybe this person's a millionaire. And so now you say, oh, more fingers means more income, or something like that. Okay, that would be a bad type of conclusion or type of association to draw there. Okay, So again, here is, just one value that throws everything off. That, throws off the analysis. Okay, and if all your data points have the same x, we cannot establish a relationship with y. Okay, and then lastly, you have a non-linear relationship, okay? And so correlation is not appropriate here. Okay. So let me give you another clicker question here. All right. So we will say you gather data on two variables, x and y. Okay. You calculate the correlation between them. And find that r is equal to -0.92. Okay, so this means direction is negative and relationship is strong. Wait, you know what? Let me just, this is like the wrong, let me just say x and y have a strong negative relationship. B, x and y now have a, we'll say, moderate negative relationship. C, x and y have a strong positive relationship. And we'll say, okay, we'll say moderate. And last, we'll say we cannot answer this question. Okay. Oh yeah. Strong and moderate. Well, I don't want to give away too much, but I think I've established some guidelines in the notes. Generally, 0.9-ish is a good break point. But, Okay, we'll get your clicks in, please. Okay, we'll hit stop. Okay, and the answer is indeed E. We cannot answer this question. Again, just knowing the correlation, you don't know if it's there's a linear relationship. Okay, so knowing the correlation, we cannot assume a linear relationship. We must make a plot. All right, and then let's, okay, so let me give you just a few additional things regarding the interpretation of correlation. All right, so just a few key things. So number one, correlation only makes sense if it is linear. We've established this. Okay, the order of the variables does not matter. So if correlation between x and y is equal to 0.64, then the correlation between y and x is also 0.64. Correlation is if you multiply all of the variables by a constant or add a constant to all of the values, correlation is unaffected. Okay, so correlation is not affected if you multiply a constant or add a constant to all the values in a variable, for a variable. Or in other words, changing the scale or changing the unit does not affect correlation. Because changing units, that's all it is. It's just multiplying by a constant or adding a constant. It does not affect correlation. Or going along with that, correlation is not affected by the slope. Correlation is affected by outliers. Okay, so if you see outliers in your plot, you should always investigate them to see, if they're real or just possible effects. Correlation is affected by outliers, so if you see outliers, you should investigate them. Perhaps you can do two analyses, one where you've included the outliers and one where you've excluded them. So that's also a possibility. Okay, and then the last one is correlation does not mean causation. Just because two things do have a relationship does not mean that one causes the other. Okay. It could point us in the right direction in terms of searching out relationships and seeing what does cause the other, but it does not mean that one causes the other. Okay, correlation does not mean causation. All right, we'll end here for today, and we'll see you guys on Wednesday.